Good morning, everybody. I'm Matias Nochetto. I'm Vice President for Medical Services at DAN, and this morning from St. Lucia, we are with Dr. Michael Lang. Mike, how are you?
I'm well, thank you. Look forward to speaking with you.
Awesome. So what do you think of this place?
I think the backdrop here is wonderful. St. Lucia is a perfect island for conducting research, training physicians in diving medicine, and enjoying the underwater environment.
So, well, we've known each other for quite some time, but most likely some of the participants in the audience, they don't know exactly who you are. I'm sure they have seen you around for a while, but so tell us a little bit of who you are.
Well, I'll start with my early diving career, which is in Italy, mainly as a free diver. I decided early on to pursue a career in marine science, and in order to study the underwater environment, you have to get down into it. Mm-hmm. So came to California in 1978, was certified as a scientific diver at first while getting my undergraduate degree. Worked at San Diego State University as marine collector and curator for 8 years. Went on to the Smithsonian Institution as a director of the scientific diving program and also the Marine Science Network. Came back to San Diego in 2013, had family there, lots of friends at Scripps Institution of Oceanography, and got an appointment as adjunct faculty at UC San Diego in the Emergency Medicine Department. With my colleague, Dr. Karen Van Hoosen, we established the Center of Excellence in Diving in the Emergency Medicine Department, and made it into a center where we look at diving physiology, and have several focus areas such as polar diving, breath hold diving. We're very interested in public safety diving as well. So that's where we currently are. My involvement with DAN started in 1983 when DAN first expanded to the West Coast with its programs. And 1991 was awarded the DAN Rolex Diver of the Year for my contributions to diving safety. My career actually started as a marine biologist with a focus on octopus, a very interesting marine organism. Career-wise, I was sort of channeled into diving safety because of operational issues. So we initiated a research program looking at dive computers, then ascent rates and repetitive diving, which we did again in conjunction with Dan at Duke University at the time. And continued on with many operational and diving safety related symposia and workshops over the years with publications.
Yeah, thank you. So that's impressive. I mean, you've had a long career, and I mean, you're here now because you're faculty on one of our CME courses. You know, we've been running this course since 1982, so it's the longest standing course of its kind. And so your contributions are valuable because you've been around for a while, and you, as a researcher, as a scientist, many of us, when we have read things over, you know, when in our younger years, we read workshop proceedings celebrated by Dan and UHMS for a long time, and you were editor and you were an integral part of those proceedings and those workshops. So tell us about your involvement in the scientific diving world and diving research, diving medicine research in those years.
Yeah. So I served as president of the American Academy of Underwater Sciences, which is a national scientific diving organization, on 3 different occasions. I guess they couldn't find anybody else to take on the task. But early on, we were trying to solve operational problems. For example, with dive computers, when they came out in 1983, we really didn't know how to use them as far as guidelines, nor what they were based on as far as diving safety algorithms and so on. So we delved into that. With colleagues at DAN for many years, Dick Van and I did several workshops, one on repetitive diving, looking at how many dives can you do per day for how many straight days before you should really step back and let the long tissue compartments off gas. We also did one in 2011 on recreational diving fatalities, looking at the triggers and the causes of recreational diving injuries and fatalities. So yeah, we've had a very close collaborative relationship with Dan's staff, with yourself, with the current Frauke Tillmans, Dan research director. So it's been a very productive, collaborative relationship for almost 30 years now.
That's awesome. And you mentioned the workshop on repetitive diving, and I know this is a topic that, at least at Dan in the medical information line, quite often we have to, let's say, educate people on what are the risks in doing too many dives consecutively. I mean, the computer, we all know that it will try to track our exposure and do the best out of the numbers we throw at it. But so, give us in a nutshell, what is the concern of doing too many repetitive dives and why we have to consider this compound effect, right, on the gaps of knowledge that we have?
So the display, the information that the dive computer is giving you, it's basically calculating residual nitrogen time. That's based on theories.
Exactly.
So this theoretical model that is in the software of the dive computer tracks residual nitrogen that's absorbed under pressure while you're diving in various theoretical tissue compartments. Very fast compartments, 2, 3 to 5 minutes, intermediate compartments, 20, 40-minute compartments, and then very long compartments such as poorly vascularized tissues such as bone and so on, 480. The problem is the fast tissues, as you're going down on your dive, on gas very quickly, but they also off gas very quickly as you're coming back up, slow ascent rate, and a safety stop. The very long tissues that you accumulate very slowly over many dives, over many days, also take a very long time to off gas. Those are the compartments we're concerned about. If you go back to the U.S. Navy dive tables that were published in 1957, and you look at the back where the original data is of the human trials, the actual manned dives that they did to validate the tables, they only had 2 repetitive dives in a series. Not what the recreational diver does when they're at a resort like here in St. Lucia, where you can do up to 4 dives per day. Then you can do a night dive, so that's 5 dives. You can do that for 5 days straight, and most likely not experience decompression sickness. But that is very different from the earlier models where you only had 2 repetitive dives in a series.
Yeah, so those models fell short when you were doing so many repetitive dives. And on the same line of thought, you mentioned also reverse dive profiles, right? And just to give people an idea on what we're talking about is, we know that normally we have to do the deepest dive first, and then any subsequent dives, ideally, they should be shallower. So why is that important, and when do we consider 2 profiles to have a reverse profile, right? To be reversed.
So the whole concept of diving deep first and then progressively shallower within a dive, and also on subsequent dives, diving to a shallower maximum depth, comes from a mechanical constraint of the dive tables. That's where that originated. And as a matter of fact, if you look at the rules for regulations for using the Navy dive tables, it specifically says you should dive your deepest dive first and then progressively shallower. But that's a constraint of the tables where you really only use 2 variables, maximum depth of your dive and total dive time.
And assumes a square dive, right?
That's what is termed a square wave dive profile. That's not the way most divers dive. And so what happens is we're basically doing multi-level dive profiles. Usually you go to the deepest part first, and then you work your way up the coral reef, like out here. And while you're doing that is you're basically off-gassing the nitrogen that you've accumulated at the deepest part of the dive profile. Right. So again, I'm going to refer back to the original Navy tables, which nobody bothered to look at. Dive operators would contact Dan and others of us in the diving safety community and ask specifically, well, why is it that we can't do a reverse dive profile? Obviously, the computer can calculate a variety of dives of any kind of sequence. And I'll refer back to the Navy tables. If you look at the original data and the dive profiles, there were reverse profiles in those original dive profiles that they did to establish the tables. So they didn't have a problem with it. The commercial diving community doesn't have a problem with it. They can do any profile you want, and they will decompress the commercial diver. So with the dive computers, we have the luxury of having the computer mechanically do the calculations for us. So then we take that information that's provided. And when we looked at the dive profiles, reverse versus forward, it was really determined that there is no significant increased risk of doing a shallow dive and then a deeper dive within a certain window.
Exactly.
Okay, and that window was determined to be 40 feet at the time. There were no real manipulative experiments or human dives to test this, but we do have a safe working envelope of dive profiles that show in the scientific community and also in the recreational diving community that that's a perfectly acceptable risk. So the reverse profile being no more than 40 feet in depth differential.
Perfect, perfect. Awesome. And let's just switch subjects here. Those of us who know you, we know that your expertise and your passion perhaps is also polar diving. So what has been your involvement with polar diving and what brought you there, and what do you think are key elements that we can highlight to the audience?
Well, let me define the term bipolar diver.
Bipolar divers, okay.
So my first Antarctic dive was a 2-month project with Bill and Peggy Hamner from UCLA, where we spent 2 months aboard the Polar Duke and at Palmer Station, which is one of 3 stations that the U.S. Antarctic program through the National Science Foundation operates. That's our U.S. presence on the continent. And that particular project was involved with diving in blue water from ships, studying krill schools. And krill is the bottom of the food chain.
Right.
Everything eats krill. Penguins, whales, and so on. So in polar diving, that was my first exposure, and have been diving both in the Antarctic and the Arctic for well over 30 years now. In 2001, through an interagency agreement, while I was employed by the Smithsonian, I managed the U.S. Antarctic Diving Program for the National Science Foundation, meaning the training and approval of scientists who are grantees from the National Science Foundation to go to the Antarctic to dive. So there's 2 main dive sites. One is Palmer Station on the archipelago across from Chile and Argentina, and then McMurdo Station, which is the main base across from New Zealand. That's the way we get there, yeah.
And operational challenges in those extreme environments?
Numerous.
Numerous.
So obviously the cold, the seawater is super cold, so it's -2 degrees centigrade, 29 degrees Fahrenheit. And so life support equipment, regulators, and so on are very important as far as the pre-dive management of the regulators. And the problem becomes when you take a volume of air, such as in your cylinder, which equilibrates to the water temperature, -2 degrees centigrade. But then when you expand that air from a small volume of high pressure through the regulator to the second stage into a large volume of low pressure, you get another temperature drop of about -5 degrees centigrade. So now we're looking at -7 to -8 degrees centigrade, which is very cold air. Because of the exhalant breath, moisture is introduced into the second stage of the regulator, and the propensity then for ice crystals to form, and then resulting in a free flow is great. So that's one of the concerns we have. The second one, of course, is thermal protection.
Of course.
So what we do there is dry suits and undergarment layering. More recently, manufacturers have developed electrically heated undergarments that really help, especially for the hands. So yeah, those are the 2 main concerns: functioning of the life support equipment and thermal protection while diving under the ice.
And in terms of emergency action planning, what is your support when you're in a polar diving expedition if anything bad happens?
Depends
because,
on
this could be a concern also for recreational
any
divers,
remote
right?
site, really, right? So at McMurdo Station, again, it depends on the dive site. At McMurdo Station, we've had a chamber there for 30 years. We've only treated once over that period of time a potential decompression sickness case and 6 aviators. So it depends on the dive site. When we dive further away from McMurdo Station, then we basically mitigate the risk by doing more conservative profiles.
Yeah.
Very simple. At Palmer Station, there is no chamber, so that's a very long distance to get an injured diver potentially to a chamber.
So Michael, you're here now because we, guest faculty for our CME, but you've been teaching both physicians and researchers and divers for quite some time. So tell us about your teaching or your educational experience.
I was certified as a scuba instructor in 1980 in San Diego, and have served on diving control boards which monitor and develop the rules for the diving programs since 1980. First at San Diego State University, then at the Smithsonian Institution, and the last 12 years at Scripps Institution of Oceanography. So I've been teaching for quite some time. Usually, for most of my career, it's been a captive audience of scientists who use scuba as a research tool to study the underwater environment ecologically, for biodiversity purposes, archaeology, and so on, in various specialties. And we make sure they're medically fit to dive. We train them, we provide the equipment so that they have properly functioning equipment, and train them in diving procedures and techniques and so on for underwater research. I also have served for the last 5 years on the UHMS Physician Training and Diving Medicine course, which is a 2-week course we teach in San Diego, and have also been keynote speaker and lecturer for the South Pacific Undersea Medical Society, UHMS, the Undersea Hyperbaric Medical Society, and the European Underwater Barometrical Society. So not only do we increase the knowledge through our research programs and projects, but we diffuse the knowledge through a number of different CME courses, physician training courses, and through the scientific diving programs.
And through literature too, right? I mean, all these workshop proceedings we've been talking about, most of them, if not all of them, are available for free on our website. So that's cool. That's the way. That's our mission. That's what we're trying to do, is to spread out information and bridge the knowledge gap.
It's a great resource on the DAN website. Many of these publications are available for download, so it's a great resource for recreational scientific divers to gather more information. Yeah.
All right, Michael. So on the name of DAN, I want to thank you for joining us on this CME. Hopefully it won't be the last one. I hope you enjoyed it. And again, thank you for being here.
Great. Thank you for having me, and look forward to lecturing again in the future.
Excellent.